Alright, welcome back to Economics. This is Dr. Kling. Today's topic is total revenue and marginal revenue. We were just talking about different industry structures leading to different shapes of demand curves, and the basic point today is to relate the demand curve and the marginal revenue curve. I'm going to draw them as if they were straight lines. They don't have to be straight lines, but there's, let's say, a demand curve. And this is going to be a marginal revenue curve. Notice that the marginal revenue curve eventually hits the x-axis. You actually get a point where marginal revenue is negative. So to understand marginal revenue, you have to start with total revenue. So total revenue for a firm is defined as price times quantity. So if you want the more, and the reason you have a downward sloping demand curve is that the more that the firm wants to sell, meaning quantity going this way, the more it has to lower its price. So if our snow cone salesman in the local shopping center would like to sell twice as many snow cones, he's probably going to have to lower his price. He may not end up wanting to do that, but if that's what he wants, but if he wants to sell more, that's what he has to do. That's the whole idea, that if a firm facing a downward sloping demand curve is that if it wants to sell more, it has to cut its price. And then total revenue is just the area price times quantity. Okay, so that's total revenue. Marginal revenue is the change in revenue as you increase quantity. And it has two components to it. For a small change, it'll be you get the the price of the new unit of output, but you also get a negative component, which is all the quantity that you've sold before, because everybody gets the same price. If our snow cone salesman wants to sell more, a little bit more output, has to lower the price a little bit. He has to lower the price for everybody, not just for the one additional unit of output. And so there's this negative component. And so we have P minus Q delta P over delta Q. And another way, one thing you probably wouldn't notice, but I'll point out, is that this delta P over delta Q is a lot like 1 over the price elasticity of demand. So it's sort of inversely related to the elasticity of demand. So when the elasticity of demand is high, get the graph here, that would be a very high elasticity of demand. When elasticity of demand is high, you get a big delta Q for small delta P. Conversely, you get a small delta P for a given delta Q, and so your total revenue tends to go up with delta Q. Or another way of putting it is marginal revenue is greater than 0. when the elasticity of demand is low, then you get the opposite. Marginal revenue actually can be less than zero. And so if we were to draw this, so we have a demand curve, we have a marginal revenue curve. This point down here, where marginal revenue is less than zero, is a point where the elasticity of demand is low. In fact, is less than 1 in absolute value. The absolute value of the elasticity of demand is less than 1 below this point. Another point about the point where it crosses the axis is that that's the point of maximum total revenue. Now that's not necessarily the point where we want to produce or sell, but that is the point where we have the maximum total revenue. If we stop short of that point, we could get additional revenue by producing more. But once we get to that point, an additional unit of output will actually reduce total revenue. So this point here is the point of maximum total revenue. The marginal revenue is always below the demand curve because of this term. In some sense, this is what you get if you could stay on the demand curve, but you stay on the demand curve, but this is what you could get if you could stay at the same price, but you have to lower your price a little bit to sell more output, and so that's why marginal revenue is below demand. And for a perfectly competitive firm that faces infinite elasticity, so perfectly competitive, elasticity of demand is infinite, and that means it can sell all it wants at the going price, and so the marginal revenue is equal to the price. In other words, it doesn't have to cut its price to sell more, so the marginal revenue is just equal to the price. So that's the difference between a perfectly competitive firm. Remember, a perfectly competitive firm faces a demand curve that looks like this, and so demand equals marginal revenue. But for most firms that face downward sloping demand curves that are not in this world of perfect competition, which is kind of a fairy tale world, marginal revenue is below demand. So I think that's everything you need to know about demand and marginal revenue. You know that total revenue can equal zero, total revenue is at its maximum when marginal revenue equals zero. You know that marginal revenue is less than price unless perfectly competitive. And you know that